In this video, we're going to look at an introduction to graph transformations. There are three different types of transformations that we can perform. We can have translations, we can have reflections, and we can have stretches. What we're going to do in the video is build up the transformations and then look at applying them to a range of different graphs. So let's take some function. I'm going to say that we have the graph y is equal to the f of x. Now the f of x could be, for example, f of x is equal to x squared. So this is a standard parabola and we would have the vertex at the origin. So if I went ahead and drew that, let's just draw a quick sketch, this now is going to give me x squared. So we know the graph will look something like so. It will be symmetric about the y-axis and it will do something like that. So we can say now that y is equal to x squared. We can perform a range of different transformations on this graph, and that is what we're going to build up. So the first ones and the easiest ones are translations. If we're translating a graph, we simply pick it up and move it by a vector. This is exactly the same as translating a shape. It doesn't change the shape, it simply picks it up and moves it. The first one we're going to look at is the f of x minus a. If we look at this as a vector, we have a units in the x direction and 0 units in the y direction. This is simply moving the graph a units to the right. If this was positive, it would move it a units to the left. If we look at the next one, the f of x plus a, this gives us a vertical translation. So we have no translation in the x direction, and we have a units in the positive y direction. So these are our two translations. A nice way to remember them, if we have now the a on the inside, it's going to affect the x's. If it's on the outside, it will affect the y's. So let's look at a few of those. If I now had the f of x minus 3, that is going to now move the graph by 3 units to the right, or in the positive x direction. So we've got this point here, 0, 0. It would move from here now to this point right here, which is going to be 3, 0. Exactly the same graph is drawn, but we've moved it to the right by 3. If I had now the f of x plus 6, this would move 6 units in the negative x direction, or, if you like, 6 units to the left. So from here we would move out and we'd have negative 6, 0, and exactly the same shape graph. The graph remains identical. So these are both on the inside, therefore they're in the x direction. If we look at the f of x plus 2, it's on the outside, so it's going to be affecting the y coordinates, so none on the x and 2 in the positive y direction. We simply pick this graph up and move it up by 2 units. So we end up with something that looks like this, and that becomes 0, 2. So the vertex has moved the bottom of the graph from 0, 0 to 0, 2. If I look at the f of x minus 5, this is simply going to pick the graph up and move it down by 5 units. So this time, instead of being at 0, 0, it would be 0, negative 5. Or, if you like, if you transformed this graph, then it would go to 0, negative 3. We'll look at one more. We'll look at the f of x minus 1, and then we will have plus 4. We can see we have now one on the inside and one on the outside. So if we deal with the one on the inside first, we're going 1 in the positive x direction and 4 in the positive y direction. So we would simply pick the graph up, move it 1 to the right and 4 up, and redraw it. So these are translations. The next ones we're going to look at are reflections. Again, with reflections, there's no alteration in the shape of the graph. The first one we're going to look at now is the f of negative x. If it's on the inside, it's going to affect the x coordinates. This gives us now, and I'll write it here, This is a reflection, so reflect, and just jotting this down, reflect in y-axis. Or if you like, the line x is equal to 0, so y-axis. So if you think about it now, what we'd have, if I reflected this one, this wouldn't be a good one to do because it's symmetric. We would simply now reflect it across. If we had now the following, we had negative f of x. We've got the negative on the outside. Remember, this is just a 1, negative 1 lot of the f of x. We've got the f of negative 1x. This is going to reflect, so reflect in now the x-axis. It's on the outside, so the y coordinates are going to be changing. If we just think about this now, if I drew this up and I'll make it a different colour, if I did negative f of x, we would end up with something that looks like that. Remember this point right here, and we'll put them on. Let's say we had the graph now of x squared. 1 squared is 1. What we'd have here is 1 comma negative 1. We would have here 2 comma positive 4. We would have here 2 comma negative 4. So by applying this, we've simply now multiplied the y coordinates by negative 1. So those are our reflections. On different functions, this is a lot easier to see with f of negative x. It's a reflection here, but as you can see, we're going to end up now with simply the negative x coordinate. So if I reflected that, it becomes negative 1 comma 1. But the graph, you wouldn't see any alteration as it's symmetric about the y-axis. So translations, reflections, and now the most challenging ones. These are called stretches. So we have stretches. Again, we will start in the x direction, and this is quite counterintuitive. If we have the f of ax, this now is equal to a 1 over a scale factor stretch in the x direction. So scale factor stretch in the x direction. Sometimes you might hear this being called parallel to the x-axis, in the x direction. So that's what we're going to have now. So if we think about this now, all we're doing is dividing the x coordinates by this value of a. So if I had now, and in fact we'll come down here, let's go ahead and do this and hopefully get some understanding of this, because it's something that's often very, very misunderstood. Let's just draw now y is equal to x squared. So what we're going to have, y is equal to x squared, and we'll put some points on here. So it will look something like this, and we'll come up, we'll come like so. So this is now y is equal to x squared, or if you like, the f of x is equal to x squared. So I'm going to have this point just here, 1 comma 1. I'm going to have this point here, 2 comma 4. I'm going to have this point right here, 3 comma 9. I'm going to have this point right here, which is 4 comma 16. Now let's consider a version now of this, and this is the f of ax. It's on the inside, so it's going to be affecting the x coordinates. Let's say I took now the f of 2x. So this now has a value of a of 2. That means that we would divide the x coordinates by 2. But let's think reasonably about what is going to happen here. If I pick this point here, we've got 2 comma 4. In the f of x, I needed to put 2 in, and it gave me 4. The question is, what number would I have to put in here to get 4? And the answer is that x would be equal to 1. Because if I have 2 lots of 1, what I'm going to have now is the f of 2. X is 1. If I substitute that in, and what that's going to give me is this point right here. So if I put this point just here, I'm actually going to have the point here, 1 comma 4. As a result, we can see that this is going to be stretched inwards, as we've had to divide this coordinate by 2 to get the same value. So if I've got now the f of 2x, what number would I have to put in to get 16? Well, the answer is going to be 2, because 2 times 2 is 4. So I can then plot this point right here, and what we're going to have is this point, and this is going to be 2 comma 16, because I only needed to put 2 in to give me the 4 that I needed to get the 4 squared, which gives 16. As a result, we end up now with a graph that is stretched now towards the y-axis. So what we have is the following. So that's what we have. So in this case, we're simply now dividing the x-coordinates by this scale factor of 2. It's a 1/2 scale factor stretch. So if we had now the f of 1/2 x, what we would do is divide by the 1/2, which means that we would be multiplying those coordinates by 2. So if we think now what we would have, if we just look at this, we would end up with the following. If I took 2 and I half that, that would give me 1. So what we'd do is 1 squared, which would put me just here. If I took 4 and I halved it, that is going to end up giving me this point right here, because I'm going to take 4 and half it, which is going to give me 2. 2 squared is 4. As a result, we have now a graph that is going to look more like this. So it's going to be opening up something like so. So we end up round here, and we have this point right here. So what we've got is this point, which is 2, 1. With this one, we're going to have now 2, and then we're going to have on here, sorry, we're going to have 4, and that will be 4, 4. So what I've ended up doing now is having a graph that is more opened out. So if we just look at a few of these, if I said now the f of 3x, we would be dividing the x coordinates by 3. The f of 1/5 x, we would be multiplying the coordinates by 5, the x coordinates, because we end up with a 1/1/5 scale factor stretch. So hopefully that gives you an idea of why it works. If we now look at the other one, the next one we have is the a of f of x. So this now is an a scale factor stretch, so a scale factor stretch in the y direction. So in y direction, or if you like, parallel to the y-axis. So this time it is on the outside, so it's going to be affecting the y-coordinates. This one is significantly easier to understand. What I'm going to do is take this graph right here, and again, we're just going to apply some basic transformations. So if we think about it, and I'll redraw it, in fact, it won't take too long. We'll have now the standard y is equal to x squared. So if I do that, what we've got now is the following. So y is equal to x squared will look something like so. Remember, these are sketches, they don't have to be immaculate. 1, 1, we're going to have here 2, 4, we're going to have 3, 9, and then we'll have 4, 16. So what we've got now is y is equal to 1 lot of the f of x. Now if I change that, y is equal to 2 lots of the f of x, what we're going to end up doing is evaluating the function and then multiplying the y-coordinates. We've got double the amount. So what we end up with is 1. 1 squared is 1, but we need to multiply that by 2. So we're going to end up now with 1, 2, which is going to go just here. Now if we think about this, 2 gave us 4. Well, if we multiply that, that's going to give me 8. We looked at 3. Well, 3 gave us 9, but if we do 2 lots of that, we're going to end up now with 18. 4 gave us 16. Well, that's going to give me 32. So we're going to end up with something that looks like this. So again, we have now a graph that is tighter to the y-axis. So it's going to end up looking something like this. So it's a scale factor stretch in the y direction. We're just finding what the function is, then we're multiplying the y-coordinates by the scale factor. So if I said now y equals 5f of x, well, this point would go to 1, 5. This would be 2, 20. This would be 3, 45, and that would be 4, 80. We're simply multiplying them up. If we said y is equal to 1/2 the f of x, well, we're going to divide the y-coordinates by 2. So this is 1, 1/2, 2, 2, 3, 4.5, and 4, 8. So those are stretches. So let's just go over those. Translations, we pick it up and move it by a units if it's negative a in the brackets. We move it up by a units if it's on the outside, and these are the vectors. Reflections, we're going to have f of negative x, which is a reflection in the y-axis, or you're just multiplying the x-coordinates by -1. And then we have negative f of x, which is a reflection in the x-axis, or you're multiplying the y-coordinates now by -1. Stretches f of ax. You're dividing the x-coordinates by a f of x, you're multiplying the y-coordinates by a. So let's have a go at a few of these. What we've got here are two functions. So I've just drawn a couple of functions, and we might say now that the red one is the f of x. So y is equal to the f of x. And we might have now the blue one, let's say the blue one, y is equal to the g of x. So it doesn't matter, generally we use f, but as I've got two different functions, I can say that we've got g. If we look at this point right here, we've got now 2, -2. This point right here, I've got 1, 0. This point, I've got 0, 2. This point, I've got -3, 0. And this point now, I've got -6, -2. With the f of x, I've got this point just here, which is 2, 0. This one, which is 3, 2. I've got this one 0, 1, and I've got this one -2, 2. So what we're going to do is look at applying some of these. So what I'm going to do now is the f of x minus 1. I'm going to do now the f of x plus 2. I'm going to do now the g of x plus, and we'll go for plus 2 on that one. And then I will do the g of x, let's do the g of x, and we will do the g of x minus 3, and I think we'll finish with the f of x plus 1, and then we will go for minus 1 as well. So these are all translations. So we'll start off now with translations. So if I think now what's going to happen with this particular graph, all I'm going to do is now move this 1 unit to the right. As a vector, this is going to be 1, 0. So if we consider what this is going to be looking like, all I'm going to do is pick it up and move it. So this point right here, remembering this is the f of x, is going to go to here. We're going to have -1, 1. There is no alteration in the y coordinate. If we look at this one, that is going to move to this point right here. That is going to be 1, 1. The change in the x, no change in the y. This one, we're simply adding 1 to the x-coordinate, and that is going to give me now 3, 0. And this one, we're simply adding 1 to the x-coordinate, and that is going to become 4, 2. All I would simply do at this stage is redraw this. So we can redraw the graph, picking it up now, moving it 1 place to the right. And that is it. No more, no less. Okay, let's clear that one then. Let's get rid of that one. We're now going to look at applying the translation, and all of these are translation, the f of x plus 2. So with this one, I'm simply adding 2 to the y-coordinates. The x do not get altered. So if I add 2 here, that's going to move it there, and that will be -2, 4. This one is going to go to here, which is going to be 0, 3. This one is going to be 2, 2, just picking it up and lifting it by 2, and that one is going to go to there, which is going to be 3, 4. So again, if I wanted to draw this, I would just draw now exactly through here, and it would look something like that. These now are parallel. There is no alteration in the shape. There's no stretching. It's simply picking it up and moving it. In most exams, you will be expected now to write down the new coordinates after the transformations. If we look at this one, the g of x plus 2. So all I'm going to do is pick this one up and move it 2 to the left. So this is on the inside. So that one was 0, 2. This one is going to be -2, 0. We're going to pick it up and move it. So that point will go to there. That one is going to go to there. This one is going to go to here. This one right here will go to there, and this one will go to there. I would label them up clearly, subtracting 2 from each of the x-coordinates, and I would draw that. If it wasn't parallel in the two sections just here, I would check what I've done. negative 8, negative 2, negative 5, 0. We've got negative 2, 2. We've got this point here, which is negative 1, 0. And we've got this point, which is 0, comma, negative 2. So nice and straightforward with that one. I've just picked it up and moved it. Okay, let's look at this one right here. The g of x minus 3. So with this one now, we're looking at a translation in the negative y direction, 0, negative 3. So all of these, I'm just going to pick them up and move them down. This one will come off the screen. This one will come to this point right here, which is negative 3, comma, negative 3. This one will be moved down by 3 units, 0, comma, negative 1. This one will come down by 3 units, which will be 1, comma, negative 3. And this one too will move down here. So all we would have now is a graph, and we can draw that on. Let's go ahead and draw that. And it would look something like that. So the x coordinates are not being altered at all. So that's what we'd have, and then we could place it, and it looks something like so. So in the exam, we would have ample space to draw that. If we finally look at this one now, what we've got is a double translation. We've got now minus 1. We're going minus 1 in the x and also minus 1 in the y. So I'm just simply going to move this left 1 and down 1. So we've got the f of x, so it's this one, isn't it? So we're going to be moving this one left 1 and down 1. So this point now, moving from here to here, will go just here. So this is going to give me negative 3, and then we're going to have on here positive 1. So I've picked that point up and moved it. We're going to come left 1 and down 1, so that is going to be negative 1, comma, 0. We're going to go left 1 and down 1, so this is going to become 1, negative 1. We're going to go left 1 and down 1, which is going to take me to here, and that is going to be 2, comma, 1. So we can go ahead and redraw this. Let's just go ahead and redraw that, and that will be our new graph. So that is a double application, and it will look something like so. So that looks pretty good. Left 1, down 1 for each of those points. So some nice straightforward translations. Okay, let's now look at some reflections. So we've looked at reflections. So again, we've got this right here. This is going to be, in fact, we could do them on here, couldn't we? If we, no, we'll move on. Let's just put on here. So what we've got again, so this now, y is equal to the f of x. So we have the red one, and we can put the points on. So this was 3, comma, 2. We've got 2, comma, 0. We've got 0, comma, 1. And we've got negative 2, comma, 2. With the blue one, we have y is equal to the g of x, so some other function g. This point here is 2, comma, negative 2. This is 1, comma, 0. This is 0, comma, 2. This is negative 3, comma, 0. This is going to be negative 6, comma, negative 2. So let's go ahead and look at the following. We will look now at the f of negative x. We will look at negative f of x. We will look at g, in fact we'll write these in black, as we're going to be doing them in black. Doesn't matter, obviously, I suppose it's just me wanting to keep. So let's do f of negative x, negative f of x, and so negative, we might do that one as well. We'll do g of negative x and negative g of x. If you want to look at negative g of negative x, essentially just going to be reflected in both axes, and that is covered in a later video on a different course. Okay, so let's start off with then this one right here. This is just a reflection in the y-axis. So reflect in y, or if you like, you can simply multiply the x coordinates by negative 1. So if we look at this one right here, multiplying the x coordinates by negative 1 or reflecting it, well, that's a distance of 2 away, so it becomes 2, comma, 2. If I reflected this one in the y-axis, well, that would go to negative 3, comma, 2. So all I've done is simply now swapped the coordinates over. This one is quite interesting because if we multiply it now 0 by anything, we're going to get 0, or if I reflect this point in the y-axis, it's going to remain the same. We've got 2, comma, 0, so that's going to go to negative 2, comma, 0, and that will give us our f of negative x. Really straightforward, nice and logical, and we end up with that scenario. So it is now symmetric about the y-axis. So that's that one done. Okay, let's look at that one. Let's get rid of that. If we now, in fact, I'll just do one of these because we're getting on with time. Let's do now negative g of x. So this one is a reflection in the x-axis. So what we're going to be doing is multiplying the y-coordinates, if you like, by -1. So the x-coordinates don't change. So I'm looking at this one right here, and this now is a reflection. So reflection, let's put a C in there, reflection in x-axis. So what we're going to have is that point right here, and this becomes -6, +2. So the x-coordinates are not changing. This one is going to be what we call invariant. It stays where it is, because all we're doing here is essentially multiplying the y-coordinate by -1, and that's just going to leave it there. This one is going to take me down now to -4, so let's put that on there. So where have we got now? So -2, which is going to be just here. So that's going to be 0, -2. This one is going to be 2, and then we're going to have now the +2 because we're reflecting it here. So 2, +2, and again this one stays invariant, stays in the same place as we've simply got now 0. So all I would do is go ahead and do that. Okay, so that's what we'd have, and then we would go like so. Now if you then wanted to apply the next one, so you wanted to do negative g of negative x, then we would simply go ahead and reflect that in the y-axis end. So what are we going to have? We're going to have something that looks like that, and then we're going to have something that looks like that. So that now would give us the negative g of negative x. Interesting, but I will leave that one there because it's highly unlikely at this level we'd be asked to do that just yet. So these are our reflections. So we've looked at translations and we've looked at reflections. Let's go ahead and look at stretches. So what we're going to have is y is the f of x, the red one, and we've got this point which we now know is 3, 2, which is 2, 0, 0, 1. We've got just here -2, 2. Then we've got the g of x, so we can say y is equal to the g of x. We've got the coordinates just here. This one is going to be 2, -2, 1, 0, 0, 2. We've got -3, 0, and we've got -6, -2. So let's look at some stretches. So we'll do some stretches now. So if we think about stretches, I'm going to do now 2f of x. So we'll have 2f of x. We will have now on here, what should we go for? Should we go for, in fact, we'll go for 3f of x, and then we'll go for f of 2x. And then I will look at, we'll say on this one right here, we'll do something slightly different. Let's do 2g of x. So 2 lots of the g of x, and then we will do now, just thinking of a different one to do. In fact, I might just do g of 1/2 x. I'm going to struggle with that a bit in terms of the graphing, but I think it's important that we can have a look at that one as well. In fact, these are fine. Okay, I'm just thinking what I can fit on here, but at the same time giving some variation. So with this one, all we're going to be doing now is multiplying the y's by 3. So it's on the outside, so multiply the y coordinates by 3. So this one right here, we've got -2, 2. So this is the f of x. 3 lots of it is going to take me just here. The y coordinates don't change. -2, 6. The y coordinate of this point needs to be multiplied by 3. So it's going to go to this point right here, 0, 3. This one will stay invariant, or where it is, because we're multiplying the y coordinate, which is 0, by 3. And this one is going to become now 3, 6. I'm simply multiplying the y coordinates by 3. So if we go ahead, we can just do that, and it will look something like that. So that is a stretch scale factor of 3 in the positive y direction. Okay, let's go ahead and get rid of that one. And that's that one done. Let's now look at the f of 2x. This is a scale factor stretch of 1/2 in the x direction, or if you like, you're simply going to be dividing the x coordinates by 2. So if we look at this, we're on the f. If I divide the x coordinates by 2, that's going to give me -1, 2. So I'm dividing that number by 2. This one is going to stay where it is, as dividing 0 by 2 is going to give us 0. This one right here, dividing the x coordinate by 2, is going to give me 1, 0. And this one right here, dividing the x coordinate by 2, is going to give me this point right here, which is going to be now 3/2, or, if you like, 1.5, 2. So we're simply now f of 2x is a 1/2 scale factor stretch parallel to the x-axis or in the x direction. So we end up now with this graph that is now tighter to the y-axis, and that is the f of 2x. Okay, that one's nicely done, so we've just divided those. Let's now go ahead and look at 2g of x. So with this one, we're simply now multiplying the y coordinates by 2. So multiply y by 2. So with this one, what we're going to have, if I multiply this y coordinate by 2, we're going to get this point, which is going to be -6, -4. Multiplying the y coordinate by 2 here is going to leave this invariant, as 2 lots of 0 is 0. This point right here, multiplying the y coordinate by 2, well, that's going to take me up here, which is going to be 0, 4. Multiplying the y coordinate by 2 leaves this point also exactly where it is, and multiplying the y coordinate by 2 gives me now that this is 2, -4. So that is a scale factor stretch of 2 in the y direction. Now if this was -2, which would make it quite interesting, we would then reflect this in the x-axis. So if I had a -2 now, we would then go ahead and reflect it like so. Okay, let's try the last one. Let's just get rid of that, so that one's done. What we're going to look at now is, there we go, g of 1/2 x. So this time we have a scale factor stretch of 1/1/2. So what we're going to do is be multiplying, so I'm going to multiply the x's by 2. 1/1/2 is 2. Now, I'm going to start with this one because you'll see that we're going to go off the screen with this one. So that one is going to go out to -6, 0. This will stay invariant as we're multiplying the x coordinate by 2. This one is going to go out to here, which is 2, 0. This one is going to go out to 4, and then we're going to have -2. So we'll have 4, -2. So all I've done is multiplied now the x coordinates by 2. G of 1/2 x is going to be a 1/1/2 scale factor stretch. So what I'm hoping for now is when I do that, it's going to remain, and hopefully you can see when I come way out there, we'll pick up this point at -12, -2. That point stays invariant, it stays where it is, and that goes to there. So we can see that it's been stretched outwards. If we have a number now that's between 0 and 1, not including that, it is going to open it up. If it's now greater than 1, it's going to be stretching it inwards. So there we go, that's some basic work with graph transformations. Let's now go on to a few questions. Okay, so let's have a look at some questions. Describe how the graph of y is equal to f of x is transformed to give the graph of the following. So this one right here, it's on the inside. That is a translation, and I'm just going to write now that it's a translation. We would ask to be asked to describe it fully. We would write translation, and we could give a vector of 1, 0, or we could say 1 unit in the positive x direction. This one right here, B, is also a translation, and I would write the word translation, a vector of 0, -3, or it's been translated 3 units in the negative y direction. This one is a stretch, so I'd write stretch, I'd write scale factor is 2 in the positive y direction, or parallel to the y-axis. I'm just writing these down, but please make sure you're writing exactly what it is. It's a stretch, it's a scale factor of 2 in the positive y direction. I say in the positive y direction because if it was a negative 2, it would be in the negative y direction. This is a stretch, and this is going to be a scale factor now of 1/4. So SF of 1 over A, remember 1 over 4, and this is going to be in the positive x direction. So positive x direction, or parallel to the x-axis. If we look at this one, this is a reflection, so I'd write the word reflection, and we can say that that is in the x-axis. So in x-axis, or, so let's just write that in x-axis, or the line y is equal to 0. If we look at this one, that is a stretch. That is a scale factor now of 1/5 in the positive y direction. We would be multiplying the y coordinates by 1/5. This one is a reflection, and that now is in the y-axis, or if you like, the line x is equal to 0. If you want to put y is equal to 0, that would be perfectly fine. Okay, this is quite a nice one. This is going to be a stretch. It's a 1 over 2 over 3, so we would say that the scale factor is simply the reciprocal. That's a 3 over 2 in the positive x direction, or parallel to the x-axis. So all we've done is describe them. If we look now, we can just go through and see that this is a translation, that is a translation, this is a stretch, this is a stretch, this now is a reflection, stretch, reflection, stretch. On the inside, it affects the x's, on the outside, it affects the y's. Okay, it says diagram A below shows a sketch of the graph y is equal to x squared. The other graphs show 1 y is equal to x squared plus 1, 2 y is equal to x squared minus 1, 3 y is equal to x minus 1 all squared, 4 y is equal to 2x squared, and 5 y is equal to x plus 2 all squared, but not in that order. Match the diagram to the equation. So this is just x squared. We know this is a parabola, and we got a vertex at 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and so on and so forth. Negative 1, 1, negative 2, 4, and so on. So let's just go through these and look at what they are. The first one now is a translation of 1 unit in the positive y direction. This is simply now f of x plus 1. So all we've done with this one is picked it up and moved it 1 unit in the positive y direction. The next one is the f of x, and this time it's going to be minus 1. So this one again is a translation, and it's of 1 unit in the negative y direction. Just think reasonably about this. It's on the outside, so we've got no brackets, whereas we have here, so it's going to be in the y direction. So this is a translation, this is a translation, and the next one here, number 3, if we look at number 3, this too is a translation, and this is the f of x minus 1. We're picking that up and moving it 1 unit in the positive x direction. It's a translation. If we look at number 4, so number 4, this is going to be a stretch. And we can say this is a scale factor, let's write this in, scale factor 1 over 2 stretch, so stretch in x direction. So that is the one where we're going to see a change in the shape. If we look at the last one, number 5, that again is a simple translation. This is the f of x plus 2. That is going to be moving now 2 units in the negative x direction. So if we look at these, all of them but one should be the same shape. The only one that's going to alter the shape now is this one right here, as it's got a stretch. If we look at the graphs, quite clearly it's this one right here. So we can say now that this is going to be y is equal to 2x squared. Okay, so let's now do that one. So that one's gone. That's nice and straightforward. Let's look at the other ones. The first one here, it has been moved up by 1 unit. So if we look at this, the only ones that have been moved up or down are these two. So this one we can see now that this has increased by 1 unit. So we've gone from 0, 0 to 0, 1. So this is going to be the f of x plus 1. So y is equal to the f of x plus 1. And that is that one right there. I would suggest not scribbling over these in the exam just in case you make an error, but as you can see it's fairly straightforward. So that one's sorted. So that one is done. The next one should be relatively easy because it's the only other one we've got now being translated in the y direction. So this one now is the f of x minus 1. We've gone from 0, 0 to 0, -1. So that one is also sorted. This one right here, we've got a translation in the positive x direction of 1 unit, and this one a negative translation of 2 in the x. We can see now that this has gone from 0, 0 to now 1, 0. A nice way to think about this, if you're still not happy with this idea of why it's negative, if we think now y is equal to x minus 1 all squared. Now at this stage, to get naught out of it, we put naught in. Naught went in and then naught come out. What number would I have to put in here for x to make it naught? Well, the answer is 1, because if we have 1 minus 1, that is naught. So I need to put in 1 to end up with it being naught. And hopefully that's why it makes sense. Now if we had f of x minus 2, we'd have to put now the number 2 in, so 2 minus 2 to get naught, to yield the same y value. So this one right here we can write on, so let's write that on. This one is the f of x minus 1, translation of 1 unit in the positive x direction. We're left with the task now of just writing that this is the f of x plus 2, which is fairly straightforward, as we can simply see now that this has moved to -2, naught from 0, 0. And again, if you wanted to think about this, if we had y is equal to now x plus 2 all squared, what number would I have to put in here to give me y is equal to 0? Well, the answer is -2, and that's why we've moved it to the left instead of the right. I was kind of avoiding that as we were going through, as it's addressed in a later video, but hopefully that makes some sense. Okay, let's go ahead and look at one more question. We're told the diagram shows the curve with equation y equals f of x, which crosses the coordinate axis at the points 0, 3 and 4, 0. Showing the coordinates of any points of intersection with the coordinate axis, sketch on separate diagrams the graphs of y equals 3 f of x plus 4, negative f of x, and f of 1/2 x. So let's just clarify what each of these are going to do. This is going to be a stretch. It will be scale factor now of 3, and that will be in the positive y direction. This is an example of a f of x. A is on the outside, it's a stretch, it's a scale factor of 3. This is going to be a translation. We can see it's on the inside, it's going to affect the x coordinates, and it's going to be now -4, 0. We're moving 4 to the left, or 4 units in the negative x direction. This is going to be a reflection, and this is going to be in the x-axis. So in x-axis, or we're going to simply be multiplying the y coordinates by -1. This one is a 1/1/2, so this is going to be a scale factor now, stretch of 2 in the x direction. So let's just put stretch, scale factor 2 in the x direction, or we're going to be now multiplying x coordinates by 2. So all I'm going to do is very rough sketches, and I'm just going to do them up here, and we'll just whip through these very quickly. So the first one, remember, they are sketches. You're looking at the general shape, and you're looking now at the points of intersection. So if we do 3 f of x, we need to multiply this one by 3 as we're multiplying the y coordinates. So what we'll have is this point here, and that will become 0, 9. This point will remain the same, as if I multiply y, the y coordinate, which is 0, we're going to get 0. So I'm going to put that on, and I'm going to show that there is a stretch. So it's being stretched in the y direction, and it will look something like so. They won't have that kink in there. I was just trying to avoid it. So we need to put on that that point is 0, 9. We need to put that point is 4, 0, and we can say that this is y is equal to 3 f of x. I would write to the examiner as well, scale factor stretch of 3 in the positive y direction. Just in case they don't see that I'm putting this stretch on, it's being stretched, so it's elongated. Okay, the next one, all we're going to do is pick this up and move it. In fact, I'll do these. Let's just see if we can get some space. I'm trying to avoid moving too far away. I appreciate that isn't a brilliant a brilliant sketch, but hopefully we can get an idea. So what we're going to do is the following. We need to now state any points of intersection. So if we just do the next one, what we're going to have is the following. Let's grab the pen. This point is going to move now to the origin. So we're subtracting now 4 from the x coordinates, and it's going to be the same shape. So what we'll have is something that looks like this, and it'll come round, and we can simply say that this point is going to be 0, 0. We've got quite clearly we've got a point of intersection with the y-axis, but this point becomes irrelevant. Now you might want to put on there that you have -4, y, just to show that you've moved that, but this is all we need to show. So y is equal to the f of x plus 4. Horizontal translation, 4 units in the negative x direction. If we do the next one, we need to reflect this in the y-axis. In the x-axis. So let's just do that. I'll do that one here. And I apologise that these aren't brilliant, but hopefully you're getting some understanding of what's happening. So all we're doing here is taking this 0, 3, and we're going to place it just here at 0, -3. We've got the 4, 0 and the 4, 0 remains because we're multiplying the y coordinates by -1, and the shape remains the same. So the shape will come through and look something like so. That's not brilliant, but it gives us some idea, and I'm going to write clearly to the examiner what I'm doing. Okay, let's just finish with the last one, and I think I will give this one a bit more space because I feel those aren't that great. What we've got here is the f of 1/2 x. So I'm going to be multiplying the x coordinates by 2. If I multiply this x coordinate by 2, I will still have the point 0, 3. So this point will be 0, 3. But this point now will become 8, 0. So I'm going to have 8, 0, which will be here, and then this will be stretched out like so. So it will come through here like so. That's not brilliant. You can see it should be coming through there. Drawing on the tablet is an absolute nightmare, but we can say that is y is equal to the f of 1/2 x. I need to show that there's a scale factor stretch of now 1/1/2 in the positive x direction. So there we go. Graph transformations, we've looked at the different transformations, we've looked at applying them, we've looked at describing them, and now we've gone ahead and looked at some sketches. I think if I wasn't 47 minutes into a video, I would have spent a lot longer on these, as it's important to show them. But hopefully it hasn't hindered your learning of this in any way. If you're ever unsure that your graphs look poor, just write exactly what you've done for each.